Example 3. Write the vector in component form. Right answers using exact values or to 4 decimal places as appropriate. All right, if you look at the pictures here, we have 2 of them. We have just a vector in the plane. There's no grid. You basically are given the direction angle and the magnitude of the vector. Okay, and that's the same for both of these. So what we have to do is write the vector in component form. Okay, so A is the horizontal component, B is the vertical component. So based on the given information, we have to figure out these components and then write our vector in that format. Okay, so let's take a look at example A. Okay, so here the vector U has magnitude 3 and the direction angle is 130 degrees. Okay, so what we're trying to do is rewrite this vector in a different format. We can call it vector U, but we can also write it like this in component form. We just need to know what the A and the B are. Okay, so remember what A and B are in terms of the picture. Your vector, since it's a position vector, you're starting at the origin. The initial point is right here. And whatever this terminal point is, it has coordinates A and B. Okay, we're trying to figure out the A and the B. Okay, if you draw straight down, okay, and that's not very straight, but if you draw straight down and make a right triangle here, this distance is going to be your A value. This distance is going to be your B value. Okay, so that is what we're trying to figure out. Okay, so we need to use the formula that we learned, okay, to get the horizontal component. This is going to be the magnitude of the vector times the cosine of the direction angle. Okay, so this is simply going to be 3, that's the magnitude, times the cosine of 130 degrees. Okay, so let's punch this into the calculator. 3 times the cosine of 130 degrees. Okay, so we get some ugly decimal. Okay, so let me write this out. Negative 1.92836829. Okay, and we are told in the directions to round to 4 decimal places. The directions also mention, if you can get an exact value, give that. 130 degrees is our direction angle here, and 130 degrees is not on the unit circle. So therefore, we have to go to the calculator, and we will end up with a decimal. Okay, but if you had an angle like, I don't know, 210 degrees, that's on the unit circle, then you would be able to get you'd be able to get the cosine exactly, and so you would end up with an exact answer. Okay, so just keep that in mind. All right, if I round this value to 4 places after the decimal point, so we've got 9283, there's a 6 that's coming afterwards, so we're going to round this to negative 1.9284. Okay, we need to get the we need to get the vertical component now. So to get the vertical component B, that's going to be the magnitude of the vector times the cosine of the angle. I keep writing this wrong thing. Sorry, guys. It is going to be the magnitude of the vector times the sine of the angle. Okay, horizontal is cosine and vertical is sine. So this is going to be 3 times the sine of 130 degrees. Okay, so this is going to be 3 times the sine of 130. Okay, so here it is. Okay, so 2.298133329. Okay, so here we go. Let's round. We need to go to 4 places after the decimal point. So 2981. There's a 3 that comes after it. So we will just keep it a 3. So this is going to be 2.2981. Okay. So that's it. Okay. We can write our vector now in component form. Okay. We actually know this terminal point is approximately negative 1.9284. comma 2.2981. The signs make sense. You should have a negative horizontal component and a positive vertical component because we are in quadrant 2. Okay. The whole goal of this problem was to write the vector in component form. We can say that vector u can also be written this way. You always put the a value or the horizontal component first, and then you put the vertical component. Okay, and so this is the answer we are looking for. Okay, writing this vector in component form. Okay, make sure you put like the brackets that look like angles. Okay, because if you put parentheses, that's referring to an ordered pair, just a point. You want to write down a vector, so you have to use vector notation. Okay, all right, let's try the one in part B. Okay, we are in quadrant 4 here. Okay, this time we have an angle marked on here that's negative 35 degrees. Our vector's in quadrant 4 and it has a magnitude of 5. Okay, so same rules apply. Okay, we're trying to break this up into component form. If you draw straight back to the x-axis here, okay, to make a right angle, this is going to be the horizontal component. This is going to be the vertical component. So we're trying to figure out the A and the B here. Okay, so we need to use our formulas. Okay, so we know to get the horizontal component, this is going to be the magnitude of the vector, and the vector is V here, times the cosine of the direction angle. And to get the vertical component, it's going to be the magnitude times the sine of the direction angle. Okay, well, when you look at this, okay, the direction angle is not negative 35 degrees. Okay, that's the angle that's shown in the picture. But remember, by definition, a direction angle has to be positive. Okay, so I'm going to draw the direction angle on here. To draw the direction angle, you need to start at the positive x-axis, rotate counterclockwise until you get to the vector. So this orange angle is going to be theta. Okay, how do we get it? Well, we know if we go one entire revolution, that's 360 degrees. And so we need to subtract out 35 degrees. Okay, so if we do this here, let's see, 360 minus 35, that means this orange angle is 325 degrees. 325 degrees is going to be your direction angle here. Okay, so you have to use the correct direction angle so that you come up with the correct signs, meaning either positive or negative of your components. Okay, so now we can plug in. Okay, so the horizontal component, it's going to be the magnitude of 5 times the cosine of 325 degrees. Okay, so if we go to the calculator, this is going to be 5 times the cosine of 325. We are expecting a positive answer because we are in quadrant 4. So the horizontal piece needs to be positive. Okay, so this is going to be 4.0957 60221. Okay, I'm going to round to 4 decimal places. Okay, so 0957, there's a 6 that comes after, so I will bump up the 7. This is going to be 4.0958 approximately. To get the vertical component, which should be negative, okay, this is going to be the magnitude of 5 times the sine of 325 degrees. Okay, so this is going to be 5 times the sine of 325 degrees. It's negative as expected. Okay, so this is going to be negative 2.867882182. All right, and we will round to 4 places after the decimal point. So we've got 878. There's an 8 that comes after it. So we will round this component to negative 2.8679. Okay, so you've got your horizontal component and you've got your vertical component. Remember what that means. This terminal point of the vector its xy pair, its point in the plane, is approximately 4.0958 and then negative 2.8679. Okay, that is that terminal point. Those are the coordinates of the terminal points. Okay, that's what the components tell you. Okay, we need to write our vector in the correct format. Okay, so just like we did above here, above in part A, okay, we're going to go ahead and say for this problem, vector v, if you write it in component form, we need to write our a value down first. It is approximately 4.0958, and then the vertical component is approximately negative 2.8679. Okay, so here is the second vector. Okay, so just a couple of things from working this problem. Remember, you have to use the direction angle. Okay, so like we had in part B, you were given something that was not the direction angle. So you had to subtract 35 from 360 to get the correct direction angle. Direction angle has to be positive. Okay, if you're using the formulas that we learned, you have to plug in the direction angle itself. If you instead decide to use a reference angle, meaning the angle inside the right triangle, you can do that. It'll give you the correct number, but you do have to go back and adjust for signs, positive or negative, okay, depending on the quadrant. Should your horizontal component be positive or negative, and then the same thing with the vertical component depending on the quadrant, should you have a positive value or a negative one. Okay, so just keep that in mind. You can do it either way, either from the formulas, or you can just simply draw out the situation and use a reference angle.